Imagine two countries literally drifting apart each year, creating new ocean floor directly between their landmasses. This incredible geological dance constantly reshapes Earth's surface and the nations we inhabit, often unnoticed. Our planet's surface comprises enormous, interlocking pieces called tectonic plates, much like a cracked eggshell. These immense plates, some carrying entire continents, are in perpetual, incredibly slow motion across the globe. Understanding their movements unlocks secrets behind majestic mountains, deep ocean trenches, and powerful earthquakes. This geological ballet profoundly influences where countries are located and their unique natural characteristics. From towering peaks to vibrant volcanic islands, plate tectonics sculpts our world in astonishing, dramatic ways. These processes define national borders and contribute to the distinct landscapes we often take for granted. The mechanism behind this global transformation involves convection currents deep within Earth's molten mantle layer. Heat from the planet's core causes molten rock to slowly rise, spread, cool, and then sink again in a continuous cycle. This powerful, sluggish current drags the rigid tectonic plates along, dictating their direction and speed of travel. Where plates pull apart, molten magma rises to fill the gap, creating new crust and expanding the ocean floor gradually. This phenomenon is most evident along mid-ocean ridges, vast underwater mountain ranges stretching for thousands of miles. Iceland, a stunning island nation, sits directly atop the mid-Atlantic ridge, where two major plates are separating. You can literally stand with one foot on the North American plate and the other on the Eurasian plate there. This ongoing separation causes the island to grow wider by several centimeters every single year, adding new land. But this slow separation isn't the only dramatic event occurring. Plates can also collide with immense force. When two continental plates crash, neither can easily subduct, forcing the crust upwards to form colossal mountain ranges. The majestic Himalayas, Earth's highest mountain range, continues its slow ascent because India pushes into Eurasia. This collision has been ongoing for millions of years, continuously raising peaks like Mount Everest to incredible heights. Wait until you discover how different types of plate collisions shape the very existence of entire island nations. When an oceanic plate collides with a continental plate, the denser oceanic crust typically dives beneath the continent. This process, called subduction, generates intense heat and pressure, melting rock and forming volcanoes along the edge. The Andes Mountains in South America, a long chain of active volcanoes, are a direct result of this oceanic plate subduction. Japan, Indonesia, and the Philippines exist as archipelagos formed by the intense volcanic activity of subducting plates. These island nations are part of the Ring of Fire, a horseshoe-shaped zone of frequent earthquakes and volcanic eruptions. And then something unexpected happens, where plates slide past each other horizontally, creating immense friction. The San Andreas Fault in California represents such a transformed boundary, where the Pacific and North American plates grind. This lateral movement builds up enormous stress, which is periodically released as powerful, destructive earthquakes. Even continents themselves are slowly splitting apart, creating new oceans over geological timescales. The East African Rift Valley provides a dramatic example of a continent beginning to tear apart, forming new plate boundaries. Lakes and volcanoes dot this region, hinting at the future ocean that will eventually separate Eastern Africa. Scientists meticulously track these movements using GPS, revealing that continents shift at speeds comparable to fingernail growth. Australia, for instance, moves northward faster than any other continent, drifting several centimeters annually. These constant, imperceptible shifts slowly but surely redefine the geography and geology of every country. The Mediterranean Sea is slowly closing as the African plate pushes northward into the Eurasian plate over eons. This long-term geological pressure creates the complex, rugged landscapes and active seismic zones seen in Italy and Greece. Understanding these plate interactions helps predict natural hazards and comprehend a country's fundamental geological makeup. The impact of these shifting plates is profound, shaping not only landscapes, but also national identities and economies. Countries located along plate boundaries often experience frequent seismic activity, requiring resilient infrastructure designs. Coastal nations near subduction zones benefit from nutrient-rich upwellings, supporting diverse marine ecosystems and fisheries. Volcanic regions while hazardous, often boast incredibly fertile soils, ideal for agriculture and supporting large populations. Iceland harnesses its intense geothermal activity for renewable energy, providing nearly all its heating and electricity. New Zealand's dramatic fjords, geothermal areas, and active volcanoes are direct consequences of its complex plate boundary location. This geological dynamism attracts tourists seeking unique natural wonders, boosting local economies significantly. The Red Sea continues to widen, slowly separating the Arabian Peninsula from the African continent over vast stretches of time. This ongoing divergence creates new seafloor, influencing regional geology and potentially future geopolitical landscapes. The formation of rich mineral deposits, like copper and gold, often correlates directly with ancient or active plate boundaries. Countries situated on stable continental shields, far from plate edges, typically experience fewer earthquakes and volcanic events. Such geological stability provides different advantages, influencing urban planning and resource management strategies. The very distribution of land and sea, crucial for trade and climate, is a direct outcome of plate tectonics. Coastlines constantly evolve, with some areas rising and others subsiding, impacting human settlements and ecosystems. Consider the unique biodiversity found in isolated regions, often created by continental drift and ocean formation. The separation of landmasses over geological time led to the evolution of distinct species, like Australia's marsupials. Even the global climate is subtly influenced by these changes, as mountain ranges alter wind patterns and ocean currents. The distribution of natural resources, from oil to precious metals, is inextricably linked to ancient tectonic processes. Understanding a country's geological history helps uncover hidden mineral wealth and predict potential natural hazards. The ongoing movement of plates means that no country's geography is truly fixed. It is always in a state of flux. This continuous transformation means maps are merely snapshots of a perpetually evolving, dynamic planetary surface. Every earthquake, every volcanic eruption, is a direct reminder of the powerful forces constantly at work beneath our feet. These geological forces continue to shape the world we inhabit, defining our countries and their unique characteristics. From the highest peaks to the deepest ocean trenches, plate tectonics is the master sculptor of our planet's face. The sheer scale and power of these geological processes are truly mind-boggling, shaping entire civilizations over millennia. These fascinating facts reveal how much of a country's identity is forged by the dynamic, shifting nature of Earth itself. The Earth is a living, breathing planet, and its constant geological motion continues to amaze and influence us all. Ultimately, the story of countries is inseparable from the incredible, ongoing saga of our planet's moving plates. If you found this fascinating, subscribe for more incredible stories exploring the hidden wonders of our world. Want more mind-blowing facts? Hit subscribe and join our journey of discovery, and let me know your favorite fact below.